Part 3, we're doing example 3, and the only difference is rather than being given a particular coefficient or property, we're just being given the graph. So let's try and create, and the other difference, we have to create both a sine and a cosine function because, as we know, sine and cosine look the same on a graph. The only difference is that they kind of have a phase shift that separates them. So when I do these types of problems, first thing I like to do is actually go in through the middle here and draw my median. Perfect straight line, but anyways, it gives us kind of a point to reference here for both the amplitude and the vertical shift. So starting with amplitude, I'll just go over here and say amplitude is equal to what? So what we see here is that midline of our graph, whether it's sine or cosine, is down here at -3. And if we trace the peak across, the peak of this is at -1. So the distance between peak and median is 2. So our amplitude is just 2. Oh, or I can write a 3 in there. All right, here we go. Let's try that again. Amplitude is 2. The other thing we can do at this point, kind of easy, since we're already here, is our vertical shift. We talked about how the midline right here is clear down at -3, and we know that the parent function of like the standard graph, sine and cosine, that median is right here at the axis here. So we've got a -3. The other thing we can talk about here are the period of this graph starts here, the bottom of the valleys here and here. So we have 19 pi/6s to get back to the y-axis, plus another 5 backwards here to get to -5 pi/6. So that total, let's call that the PD, is 24 pi/6. Which is just simply 4 pi. Let's see, so amplitude, period, vertical shift. Our phase shift is our last one, so I'll just call that our PS. And the thing about this, the amplitude, vertical shift, all that, it doesn't matter which one we're talking about, sine or cosine, those properties are going to stay the same. The difference is actually right here in our last property we're determining, which is our phase shift. So they called out this point pi/6 for a reason. Not only to help us with our vertical shift and things like that, but we know the parent graph for sine. So I'm going to put sine phase shift, and I'll add another one, cosine. So if we go to sine, we know sine starts at 0. Sine of 0 is 0. Then we go up, and then we go back to the midline, and then down again. So our phase shift in this case for sine is pi/6. Cosine, parent graph, cosine of x, starts at 1, because cosine of 0 is 1. So that means that our cosine graph is actually shifted way over here instead of the y-axis. So that one gets a 7 pi/6. So from here, I'll just start writing. I'll tell you what. To find b, I'll just add that right down here. So our period is equal to 2 pi over b. We determined that the period in this graph is 4 pi. So that's 2 pi over b equal to 4 pi. So we need to find b in order to write the equation. If I just stay here and say y equals You know what? I'm going to change the color. Y equals A times sine. A is our amplitude, just 2, 2. Sine of B. So here's where we got to come up with B. If we flip B and 4 pi, if they've switched places, then our pi is reduced to 1, 2 over 4 is a half. So sine of 1/2 of x minus our phase shift. Phase shift for sine, since we're using sine, is pi over 6. And our vertical shift, -3, so minus 3. If we did cosine, it looks like this. Same thing, all the way up to the point where we say x minus, then we say 7 pi over 6. I missed a parentheses there. There we go, -3, and we're good to go. That gives us example 3. Let's see, I'll go a little bit quicker. We're going to try and squeeze in example 3 part 2 here. Instead, what I'm going to do, maybe to condense this, I'm going to say A equals our amplitude. Well, let's see, where's our midline at here? So our valley is at -3, our peak is at 5. So that has a total distance, top to bottom, of 8. So another way to finding, if we don't have a nice midline identified, you can just take top minus bottom divided by 2, but or top plus. But we get a distance of, or an amplitude of 4. Because we've got, so 4 means our midline's right here, right? Because our peak is at 5. So I'll still draw it in. B, in this case, then we got to figure out, let's see, well, 2 pi over B is equal to the period. The period in this case, from peak to peak, well, this is saying that from peak to valley, we go 1 unit. And then from here to here, we must go another 1 unit. So the answer is just 2, right? So from -0.5 back up, we're at 1.5. So that total distance, the period is 2. So if we flip B and 2, we get 2 over 2 is 1. So we just get B is equal to pi. C is that phase shift. And in this case, it looks like, if we're talking sine, let me see, sine C for cosine. Because again, the phase shift is different. For sine, I'm going to say, there's lots of ways to call it out. Let me make this the point that we should have started at. So we shifted to the right 1 unit. So sine C is 1. For cosine, the peak is clear over here. That was 1.5. So I'll keep my phase shifts positive. And our D, we said we were up 1 unit from where we should have been. So go back to our black lettering and say y equals 4 times sine of pi times x minus 1 plus 1. Or we have y is cosine, so 4 cosine of pi x minus 1.5 plus 1. There you go. and that's how you do those examples. At this point, that's as far as we've gotten for the lessons. There are other problems down here with applications, but that'll be a separate video. So there's example 3.